Have you ever picked up a fruit, looked at its bright green skin, and just assumed that's simply how nature made it? What if I told you that green is not just a color? It is a secret code written inside every one of these fruits, and once you understand it, you will never look at your fruit bowl the same way again. Some of these fruits are green because they are hiding something. Others are green because of a genetic accident that scientists only fully understood a few years ago. And one of them on this list is green for a reason so strange that even farmers who have grown it for decades still get it wrong. Stay with me until the end, because I'm going to leave you with 10 small mysteries, one for each fruit, and I promise the final answers will genuinely surprise you. Let's start peeling back the layers. The first fruit on our list is the kiwi. Slice one open, and you see that shocking lime green flesh scattered with tiny black seeds like a night sky flipped inside out. Most fruits lose their green color as they ripen because the chlorophyll inside them breaks down and reveals the reds, oranges, and yellows hiding underneath. But the kiwi refuses to let go of its green. Even when it is perfectly ripe, soft, and sweet, it stays green. For a long time, scientists were puzzled by this. Why would a ripe fruit hold on to a pigment that is normally associated with being unripe? Here is your first mystery. Somewhere inside the kiwi's genetic code is a switch that should turn off the green color as the fruit matures, just like it does in almost every other fruit on Earth. That switch appears to be broken, or perhaps it was never meant to turn off at all. Which is it? A mistake of nature or a deliberate survival strategy? Keep that question in your mind, because the answer connects directly to why this fruit has survived in the wild for millions of years. Next, we move to the avocado, a fruit so unusual that many people do not even realize is a fruit at all. It is technically a giant single-seeded berry, and its skin ranges from dark bumpy green to almost black, depending on the variety. But here is where it gets interesting. The flesh inside stays a soft yellow-green no matter how ripe the avocado becomes. And unlike almost every other fruit, it never turns red, orange, or purple. Bananas turn from green to yellow. Tomatoes turn from green to red. So why does the avocado break the rules? There's a hidden clue in how this fruit evolved, tied to an animal that went extinct thousands of years ago. Scientists believe the avocado was designed by evolution to be eaten by a creature far larger than any animal walking around today, and that its green color was never meant to signal ripeness to us at all. Here is your second puzzle. If the avocado was not designed with humans in mind, what ancient creature was it actually trying to attract? And why would that creature not care about color the way we do? Now, let's talk about limes, the small green citrus fruit sitting in almost every kitchen. Limes and lemons come from remarkably similar trees. So why does one stay green while the other turns bright yellow? The answer is not as simple as most people think. It is not just about ripeness. In fact, limes can actually turn yellow if you leave them on the tree long enough, but almost nobody does that. And there is a very practical reason why. Farmers, grocers, and even you at home are participating in a decision that has nothing to do with taste and everything to do with a chemical reaction that begins the moment the fruit is picked. Here is your third mystery. If limes are capable of turning yellow just like lemons, why does virtually every lime you have ever eaten in your entire life stay green? What is stopping this natural transformation from happening right in front of us? The fourth fruit takes us to something you have probably eaten 100 times without ever wondering about it. The green apple, most famously known as a Granny Smith. Unlike red apples, which ripen into deep red or golden yellow, the Granny Smith stays vividly green from the moment it is picked until the moment it starts to spoil. This variety was not created in a laboratory. It was discovered by complete accident in the 1860s by a woman in Australia named Maria N. Smith, who found a strange seedling growing near a creek on her property from a discarded pile of French crab apples. What she stumbled upon turned out to be a genetic combination so rare that it has never been reliably recreated from seed since, which is why every single Granny Smith apple tree in the world today is a clone, grafted from the original tree's genetic line. Here is your fourth puzzle. If this apple's exact genetic recipe cannot be recreated by planting its seeds, and every tree must be cloned from the original, what does that tell us about how fragile this shade of green actually is, and what would happen if that original genetic line were ever lost? Green grapes bring us to our fifth mystery, and this one might be the most surprising of the entire video. Green grapes are not simply unripe purple grapes, as many people assume. They are an entirely separate genetic lineage. In fact, the difference between a green grape and a red or purple grape comes down to a tiny mutation in a single gene responsible for producing anthocyanins, the pigments that create red, blue, and purple colors in fruit. When this gene is switched off, the grape simply cannot produce those pigments, no matter how ripe it becomes. So it stays green or turns a pale golden color instead. Here is your fifth puzzle. Scientists have identified the exact gene responsible for this color switch, and it turns out the same gene is connected to something in the grape that has nothing to do with color at all, something related to how long the fruit can survive after being picked. What do you think that hidden connection might be, and why would color and shelf life be linked inside the exact same strand of DNA? Our sixth fruit is a honeydew melon, with its smooth pale green rind and its even paler green flesh inside. Unlike cantaloupe, which develops a rough-netted skin and deep orange flesh as it ripens, honeydew stays remarkably uniform in its green and cream tones throughout its entire life cycle. This creates a real problem for farmers and shoppers alike, because unlike most fruits, you genuinely cannot tell if a honeydew melon is ripe just by looking at its color. Here is your sixth mystery. If color will not tell you when a honeydew is ready to eat, experienced farmers rely on a completely different sense to figure out, one that has nothing to do with sight or touch. What sense do you think they use, and what physical clue does a truly ripe honeydew give off that a green, unripe one simply does not? The seventh fruit is one that many people outside of South Asia have never even heard of, the Indian gooseberry, also called Amla. This small, hard, pale green fruit looks almost like an unripe olive, but it holds one of the most extreme concentrations of vitamin C found anywhere in the plant kingdom, far surpassing oranges. Its green color remains constant its entire life, and it is prized in traditional medicine systems that are thousands of years old. Here is your seventh puzzle. Despite containing an enormous amount of vitamin C, a nutrient that is normally destroyed easily by heat, ancient practitioners found a way to cook and preserve amla for months without losing its nutritional power, using a preparation method that seems to defy basic food chemistry. What kind of preparation do you think could possibly protect something as fragile as vitamin C from heat and time? Star fruit or carambola is our eighth mystery, and it might be the strangest looking fruit on this entire list. Sliced crosswise, it forms a perfect five-pointed star, and its ridges stay a waxy, almost glassy green even when the fruit is fully ripe, only turning a soft yellow-green at full maturity, while never losing its greenish undertone completely. This fruit contains a compound that is completely harmless to most healthy people, but can be genuinely dangerous to a specific group of people with a particular health condition, to the point where doctors specifically warn certain patients never to eat it at all. Here is your eighth puzzle. What is it about this seemingly harmless green fruit that makes it one of the very few fruits in the world capable of causing serious harm to a specific group of people, while being completely safe for everyone else? Green pears make up our ninth entry, and they present a puzzle that fools almost everyone who has ever bought one. Unlike most fruits, pears do not ripen properly on the tree. If you leave a pear hanging until it feels soft, the inside will actually become mushy and grainy near the core before the rest of the fruit is ready. This means the color of a green pear skin tells you almost nothing about whether it is ready to eat, which is the exact opposite of how most people shop for fruit. Here is your ninth mystery. Farmers and pear experts use a specific physical test involving one particular spot on the fruit to determine ripeness, completely ignoring color. Where on the pear do you think this test is performed, and what are they actually checking for? Our 10th and final fruit is the Greengage plum, a small, sweet, intensely flavorful plum that stays a dusty green color even at peak ripeness, unlike almost every other plum variety which turns deep purple, red, or black. This fruit was named after a British family who first cultivated it in the 1700s, and it remains one of the few plum varieties in the world that never fully abandons its green color no matter how long it ripens. Here is your 10th and final puzzle. Despite staying green, the Greengage plum is actually considered by many chefs and fruit experts to be one of the sweetest and most flavorful plums in existence, often surpassing its darker, more visually appealing cousins. Why do you think a plum that looks the least ripe by conventional standards could actually taste the sweetest of them all? Now, before we close out this video, let's go back through every single mystery and uncover the truth behind each one, because I promise you answers, and I always keep my promises. Started with the kiwi. The reason it never loses its green color, even when fully ripe, comes down to a genetic trait scientists call stay green. Inside the kiwi, the enzymes responsible for breaking down chlorophyll are far less active than they are in other fruits, so the green pigment simply never fully degrades. Researchers believe this trait evolved because the ancestors of the modern kiwi grew in shaded forest environments in China, where staying green may have helped the fruit blend in and avoid being eaten too early by birds and animals before its seeds were fully mature, only becoming attractive to eat once it reached a specific softness that signaled true ripeness through smell and texture rather than color. The avocado's mystery connects to an idea called evolutionary anachronism. Many scientists believe the avocado evolved to be swallowed whole by massive prehistoric mammals, such as giant ground sloths and gomphotheres, ancient elephant relatives that roamed the Americas until roughly 10,000 years ago. These enormous animals did not rely on color to know when to eat. They relied on smell and size, swallowing avocado whole, and later depositing its enormous seed far from the parent tree inside their droppings. When these giant creatures went extinct, the avocado was left behind with a coloring system built for animals that no longer exist, which is why its color tells modern humans so little about ripeness compared to touch. Limes stay green for one surprisingly simple reason: refrigeration and rapid harvesting. Limes naturally do turn yellow if left on a tree or stored at warm temperatures for an extended period, because the chlorophyll does eventually break down just like in lemons. However, commercial limes are almost always picked while still green and immediately refrigerated for transport, which dramatically slows the enzyme activity responsible for the color change. By the time you buy a lime at the store, it has been deliberately kept cold enough that its natural yellowing process has essentially been paused. The Granny Smith apple's fragile genetic mystery reveals something remarkable about how apple trees actually work. Apple seeds do not grow true to their parent, meaning a seed from a Granny Smith apple will not reliably produce another Granny Smith tree. It will produce a completely random genetic mix. This is exactly why every Granny Smith tree on the planet today has been grown not from seed, but from cuttings and grafts taken from the original tree discovered by Maria and Smith over a century and a half ago, meaning every single Granny Smith apple you have ever eaten is technically a genetic clone connected to that one original tree. For the green grapes, the gene responsible for their color, often referred to in scientific literature as the color locus, is closely linked on the grapevine's genome, the genes involved in berry firmness, and how the fruit responds to stress after harvest. This close genetic linkage means that breeding grapes for a certain color can accidentally also influence how long they stay firm and fresh after being picked, which is part of why certain green grape varieties are prized specifically for having a longer shelf life than some darker varieties. The honeydew melon mystery comes down to smell rather than sight. Because the rind color barely changes, experienced farmers and shoppers rely on aroma. A truly ripe honeydew gives off a sweet, slightly musky fragrance from its blossom end, the rounded part opposite the stem. A melon with little to no smell at that spot is almost always underripe, regardless of how uniformly green or pale it appears. Amla's ancient preservation secret lies in a traditional method involving salt curing and sun drying combined with the addition of natural oils, which create a low oxygen, low moisture environment that dramatically slows the oxidation process responsible for destroying vitamin C. Some traditional preparations also involve minimal heat exposure or none at all, relying instead on fermentation and pickling techniques passed down for generations, allowing much of the vitamin C to survive far longer than conventional cooking methods would normally allow. Starfruit's hidden danger comes from a naturally occurring neurotoxin called caramboxin, along with high levels of oxalic acid. In people with healthy kidneys, these compounds are processed and eliminated normally. However, in people with kidney disease or impaired kidney function, these toxins can build up in the bloodstream and, in some documented cases, have led to severe neurological symptoms, including seizures and confusion, which is why doctors specifically warn kidney patients to avoid this fruit entirely despite it being completely safe for the general population. The green pear's ripeness secret is checked at the neck, the curved area right where the fruit meets the stem. Experts gently press their thumb into this spot, and if it yields slightly to light pressure, the pear is ready to eat, even if the rest of the fruit still feels firm and the skin remains fully green. This method works because pears ripen from the inside out starting near the stem, making the neck the very first place softness appears. Finally, the Greengage plum's incredible sweetness, despite its green color, comes down to a higher natural sugar content relative to its acidity compared to many darker plum varieties. Color in stone fruits is determined by anthocyanin production, which is a completely separate biological process from sugar accumulation. The Greengage simply never developed strong anthocyanin pigments, but its sugar development remained just as advanced, if not more advanced, than its purple and red cousins, proving that in the world of fruit, color and flavor are far less connected than most people assume. So the next time you reach for a green fruit, whether it is a kiwi, an avocado, a lime, or any of the others on this list, remember that its color is not random at all. It is a message written by millions of years of evolution, ancient extinct animals, hidden genetics, and survival strategies that most of us walk past every single day without a second thought. If this video changed the way you look at your fruit bowl, that is exactly what it was designed to do.